Priscilla Allan is now
Thank
at
you.
Glendowie Intermediate. She's going to introduce us to PrimeClimb, which I've put a space in, and coding. Today, Pricilla has been a bit of an inspiration to me and all the amazing things that she does with technology. Her Google sites and her enthusiasm with screencasting way back in the days when we had the realignment of NCEA. So I'm going to stop now and hand my screen over to Pricilla.
Okay, good morning. I'm going to try and share my screen now. Oh, yeah, it's all good. And go here and share. So hopefully you can all see this. What I thought I'd do first is if people can click on the Google form and fill it out, then we can get a feel for where people are at and what we need to look at. So if people just click on that link.
They may not have the page open, Priscilla. We'll drop it into the chat.
Okay, that would be cool.
In just a moment, hang on.
I'll just have a quick look at responses. So at the moment, yeah, we've only got a couple of responses. So I'll just let that
hang on
for the minute.
I'll just get there, just little things.
One there.
I'll go to your Google site page.
Okay.
And the form.
Yep.
Now I'm hoping that this will be in the chat.
Okay, so while that's going on in the background for the next 5 minutes or so, I'll just give a little bit of a background. So why was I so much into PrimeClimb? That was to do with my master's in 2015. It was on inducing mathematical flow in the classroom. And I interviewed a whole lot of sort of master's level mathematicians at Auckland Uni. And many of them said they didn't find mathematical flow, which is basically optimal engagement, until they were at uni, and that there wasn't much space for it in school. And so I then did a bit of a intervention type thing where I was trying to induce that in an after school situation. And so, you know, that was 2015. So it took me until last year before I actually managed to get students playing PrimeClimb regularly. So PrimeClimb, if you've heard of Dan Finkel, it's his game that's designed specifically for students to be learning maths with open-ended questions. And I found that when I introduced it to year 9 and 10, they absolutely loved it. And the whole attitude to maths changed and our grades went up. So from last year, if you click from my 2020 site, you can see my last year's kind of site. And it's got, like, I was looking at PrimeClimb for measurement, geometry, algebra and everything. Also, it has things like his TEDx images. So for those of you who are not familiar with PrimeClimb, this is the numbers structure, and it's all to do with prime factorization. So 2 is orange, 2 times 2 is 4, 2 times 3 is 6. So 2 times 2 times 2 times 2 is 16. So the students get familiar with the numbers, and if they can't multiply, they can use the colors to multiply. And one of the things I really love about it is that 2 is orange, so it's a different size here to here, and it's a different size again over with the 12. So because of that, it lends itself to algebra really well, because X can be a color. So back to here. So basically after my master's, I did 1 year full-time maths, you know, teaching year 13, stats and calc, and all the way, you know, down to year 9. But I went part-time, and the price to pay for going part-time was to teach only juniors. So for 2 years, I taught 3 days a week, and the 4th day I planned to mark for, but I wasn't there. So when I went back into the classroom last year, 4 days a week, I knew I could spend 1 hour a week with the 4 classes doing games, and I could still get through the curriculum. So that's where I really started to make progress. So I did do some kind of researchy type stuff where I collected student voice, and I used the same kind of tool that I used in my master's to measure flow. And I've basically could back up with their ratings and with their comments that PrimeClimb was a winner. So I've got a bit of evidence going on there. So this year I moved to primary school. Seemed like the logical move because I'm also early childhood trained, and I'm 3 days a week there. And it's been fantastic because part of my job has been kind of the maths expert. So I've got the link to, this is my 2020 site. So the big idea with PrimeClimb is the social interaction and activating students as resources for each other, which is Dylan Willem. The visualization of it, the algebra, and every time you roll the dice, you've got this open-ended question with almost endless choice. So strategy is really important. So it can be played at multiple levels. It can be very low entry and very high exit. And I moved on this year with lockdown, I started coding. So we'll start with, if we click on this one, the family of facts. I managed to code the PrimeClimb numbers using Trinket in Python. So I was interested in coding in Python, but I downloaded it on the machine and was watching a video. And then I found by watching other videos and bits and pieces that actually Trinket allows us to see, to use Python with no download. So if we grab that link here and paste it there, and I'll paste it into chat, you can actually see the Python code here and the output over here. So this is multiple levels. You're doing as simple as the family of facts and as complicated as some of the students looking at the coding. So I'll just see if I can drop that into chat. Done. Okay. So if we look at, no, I can't quite see that. I might have to go back here just to show you the code working. So down the bottom here, I can actually change the numbers. If I enter a capital P, for example, I've got pretty, and then I can enter a number. So I could go 60 and I might go 34. And so here you could say, okay, what color is which number, that sort of thing. So you can, the beauty of it is that you can use any numbers here and it's giving you the prime factorization. You can have different color schemes as well, and you can, you know, do as simple as that. So that's the first one, and as I said, you can remix the code, which we'll have a look at a little bit later. Then also I've got algebra family of facts. So this is where we can do the same thing, but we've got variables. And students can try and code and see if they can add another variable in, or you can as well. And this one here has actually just got the numbers on their own. So you can enter null and it'll just go through the numbers, or you can actually enter any number that you like and it'll give you the prime factorization. So that all links to PrimeClimb as well. And I decided a tables chart was worth coding too. And so here again, you can enter a color scheme, and you can enter, maybe you wanted to do the 6 times, and you've got like a chart of those numbers. So that's quite useful if you're playing PrimeClimb, and you're looking at numbers in maybe year 6, 7, 8. And back here, I think, with coding, the indentation's part of the structure. So when students are playing with the code, they've got to be really careful that if they muck up that structure, it all falls apart. The code's coloured, which is a really good way of sort of asking the kids the question, like, what does green do, or that kind of thing. So a good starting point for coding, I found, was this. They really got into this one. So I've even gone as far as saying suggested hack, change the number. So for example, if we change that angle to 90, oops, and push play. And if we want to spread it out a bit, we can change the length. That's the original length. And the length change. So if I made that, say, a 15 as well, that'll spread it out a bit. So I was saying to the students, try different angles. And of course, it becomes very interesting because it's the external angle. And as soon as you get like that, well, okay, you've got to change the length again. So they could spend actually quite a lot of time playing with this and getting different shapes. We were doing a Fibonacci kind of a unit, and so I coded the Fibonacci spiral, and again gave the students access to the code, and they had a bit of a play with that as well. So if people want to just jump into one of those and have a little quick play, I think this one here might be the good one for everyone to have a play on, because it's sort of not very much code. So I'll pop that in chat. And if people can click on that, that would be great. Okay, in the meantime, I'll have a look at this. So PrimeClimb, not very many people have played. Python, interesting. A lot of people have had a bit of a play on Python, a play on Scratch. Desmos is quite popular. Gapminder is an interesting one. Everything, I love it. Okay, I'm just skim reading that. So how do I teach? What have I been doing? I think with me, my website has a lot of stuff that I do. So if I click on, for example, slightly off topic, Desmos design, you can see on my website how I've made videos for the students to play with Desmos and to create all sorts, this is during lockdown, all sorts of their own moving art and just interesting things. So we had a solar system that moves, which is really cool. And yeah, students had a lot of fun. I think some of the coolest things was stuff they did that I wouldn't have thought of doing, which I thought was very super cool. So these students' work, and you can actually click on them. One of my favorites is the solar system. And so a student was doing a bit of an inquiry, and I helped her a little bit, and she got the solar system going with Desmos. So anything like that, I tend to store on my site. So you can always, if some people are just looking for something different and new, they can have a bit of a scroll down. At the moment, we're looking at Python, And you can see this is the page that the students go to. And this was ones that they were actually playing with. So I let them kind of just have a free-for-all and have a play. And I found one of the ones they really like playing with, which is not the Pythagorean spiral or Fibonacci spiral. It's actually just these spirals, and that really took their fancy, actually. There's still quite a lot of maths in there. And so they have a whole lot of code where they are basically exploring it, and they really enjoyed that. There's other ideas here too, so that students could actually make Python poems. And yeah, Mary Had a Little Lamb, that's something quite random. So that's the output. And the again, I've got the link to the code, and you can see in the code that you set up the strings, or I've got the wrong terminology, and it's very short code, and then you've got this lovely long poem. So it's sort of like the mathematics behind poetry, which is kind of quite PYP, IB, primary years program thinking. Okay, and oops, never mind. If I go back to ours. Okay, so maths with Python. Yep, we've got the PrimeClimb numbers, but we've also got these other ideas coming in. And I found that a good starting point was actually small programs, and they're mixing them rather than starting from scratch. And scratch coding, which most of you are into, if you like, I did make a whole lot of videos during lockdown. These are not maybe quite so mathy, but the videos of how to, and I had some fun with things like movement and music and random numbers, and I made some PrimeClimb quizzes as well. So the code for them is here, and there's a few videos. Going back. I've talked about Desmos, and there's just sort of random learning. And the other thing is, because quite a few people, I think they were not familiar with Gapminder. This is actually phenomenal. I'll just double check that. Where was Gapminder? Yeah, so a lot of people actually don't use Gapminder, which it's absolutely phenomenal. So fantastic videos and things, but you know, here you've got 5 variables. So you've got the income, you've got life expectancy, you've got the color of the countries, the region, and the world, you've got the colors, the size of the dot being the population, and then the 5th variable being time. So students were really interested in this. They absolutely, this is year 6, 7, and 8. Absolutely, well, 7 and 8 actually. So here, if we look at that, you can see the life expectancy with the Spanish flu and the First World War go down, and they're amazingly aware of that and able to kind of make sense of the data. So I got them to do a bit of a PPDAC investigation using Gapminder. And so this was year 7, and some of them were looking at power use, for example, and saying they thought that in Iceland they'd use more power than near the equator, and they actually managed to prove it. So they changed their variables on the X and Y axes and did their whole investigation, and it was great. Further down here, you've got all sorts of other videos and all sorts. So Gapminder is just an amazingly interesting way of looking at the world. And like I said to the kids, I would have loved history if I'd have had Gapminder, because you know, if you watch it, you're seeing what's happening to a particular country. You can actually click on a country and it'll trace that country, and you can see it changing over time. So you basically ask the question of what's going on, why did that happen? So Gapminder is well worth a little bit of a look at, I would suggest. Okay. So I think we should say, what questions do people have about Trinket and Python? And are we playing? That is the question. Are people managing to get into Trinket and have a play? A look at chat. Oh yeah, a lot of people have read the book. Okay, I'll go back to our thing here and see if I can see any questions. With the introducing it into the classroom, I'm in an interesting position because I've actually, after lockdown, gone into classrooms for just 3/4 of an hour a week into 3 Year 8 and 3 Year 7 classrooms. So I'm able to literally go in there and say, right, today we're going to do coding, or today we're going to do Gapminder, or today we look at NZ Grapher, or today we look at CodeApp. And it kind of sets the students up for when they're doing their inquiries to know these tools exist. And the students are really receptive and they just go for it. They've got no fear. In fact, I think it's partly the school and partly the age of the students that they seem to be less daunted by it than at secondary school, and much more able to play. So I think Desmos, it was a really interesting one for me in the classroom, because actually it was during lockdown that they were starting to play with graphs. And I had, for example, gone x squared plus y squared is less than maybe a squared. And having a bit of play there. So with the students, they think outside the square, and they go like this, and this kind of thing. And that was fascinating to me because I'd actually never thought of doing that. So yeah, my pedagogy, if you like, is learning through play. And so they're really enjoying learning through experimentation. And the way that I was teaching Python was like, see if you can break the program, see if you can make a difference. So if I go to my Python one here, the one that they were doing, the prime numbers, if you like, this one here, what did some of the students do? Oh, this one, I haven't got the code. Okay, hasn't got the link. There we go, remix link. Right, so I would hint to them, well, the kids go, I can't code. And I go, don't let that stop you. Can you find anywhere the radius? So they're hunting through for the radius. And so they might change this to like 120, and that one they might change to 60, and then they simply push play and it's changed. And so some of them would go, okay, of course, they have no fear, so they have a huge number. And then this is very exciting for them when they see that they've just changed one number and they've got this amazing difference. and it really does hook them in. So I guess it's that thing of, you know, can you break it? And then changing other numbers and stopping and going. And basically, if they muck it up completely, you just go back and start again. So for some of the students, they'd done coding, they were right into it. Others who'd never coded before still found that they could find things to change. And for example, the colours are easy, they're all in red, and they could change that. And people were also, for the colours, there, quite often I'd put a link in there, but you can also Google trinket colours, spelt wrong, and it should pretty much bring it up, and you get the colours with the different codings and things. So students were learning an awful lot just by playing with it, if that makes sense. Where else would we go? I'll go back here.
Priscilla, just a few comments coming up from the chat.
Yep.
As you're navigating, you might want to try to answer them. There's some questions about how you're tying this into, I guess, what the students are learning mathematically. That's my interpretation of these questions. So how do you get them to take their playfulness and turn it into some good maths learning?
Okay, so with the Fibonacci one, we'd actually done like a the Mathagon Alice in Wonderland Fibonacci Pascal's triangle task, and so this was at the end of that, so it kind of linked in. For the graphs, it's kind of the big idea. So when we were doing the moving art in Desmos, we were actually using differentiation and inverse tan to get things to behave. So we were sort of using calculus before we know what calculus is, but so we're seeing the point of maths before we have actually learnt it. For the Python stuff, of course, it linked to playing PrimeClimb. So with PrimeClimb, we'd been playing that for the whole of term 1, and so now we've got those PrimeClimb numbers in Python. So that's all connected. And of course, those other little ones, you've got all the angles in there. So the conversation about exterior angles happens while they're playing. So like if you change that angle to 90 degrees, you get a square. Why is it when you change it to 60 degrees, you were getting a hexagon and not a triangle, for example, because it was the exterior angle. So there's a lot of revision on angles and polygons with that play. And we talked about structure as well. Does that answer the question?
I appreciate your response. Other people might want to write in the chat whether they want any follow-up on that.
Yeah. Yeah, that's interesting. Only 3 periods each week with maths. So I was having 4 hours with year 9. So I could easily kind of fit it in. It's a bit harder with 3. But engagement's everything. If they've turned off maths, you just can't, yeah, you just can't reach them. You're wasting class time. Yeah, so time spent on the rich learning and covering the curriculum, I think it can sort of happen, like you can learn, if you learn through play, it can actually sink in more. So if you were at the board and saying, you know, there's sort of, these are the exterior angles of polygons, it can just kind of float over the top. But when they actually change the number and the image changes, it's actually their learning. They're learning it through exploration. So I find that sometimes we might teach it, but they're not learning it. Whereas through this, it's sort of more about their learning. Oh, how do I know what they have taken away as learning? Yeah, it's all different for different students because it's so low entry, high exit. Some students are working at quite a different level to others. So it's really the over the shoulder stuff and helping students as they go and trying to get them to discuss with each other. Yeah, so I guess when you're converting the play to understanding concepts and procedures, you still need that explicit teaching at times. You know, it's not like we're playing all the time. It's just part of it. Yeah, I think that when you're doing the coding or any of these activities, they actually require quite a bit of time. So 5 minutes as a warm-up doesn't necessarily give them time to kind of go deeper into it, particularly things like Gapminder. So it was just, there was something. PrimeClimb, yeah, is a fantastic start because once you've taught them how to play PrimeClimb and taught them to help each other playing PrimeClimb, they're actually doing all the skill and drill on their numbers and order of operations kind of stuff and strategy. So I found that a really good way to actually up their number understanding was actually getting them to play PrimeClimb and help each other. So one of the key things with PrimeClimb was getting them to voice how they got their answer. So a little bit like number talks, but through the game. So it's like you can't just go, well, I'm moving here. You've actually got to say out loud, oh, well, I'm doing this multiplication, then I'm doing that addition, or I'm doing that division, and then doing a subtraction or whatever. So they're actually saying out loud what they're doing. Studio code. I think, is that the dance studio hour of code? Yeah, I have. Yep, definitely using play to create teachable moments, but also to allow students to explore the maths in a really wide open kind of way. So you're not keeping them down. Like some of them, it's amazing to see what PrimeClimb can do and coding can do to students who actually started off not engaged. So when I've come to Glendowie School, a number of teachers and teacher aides said to me they'd never seen the kids as engaged as they are now. Some of the students that weren't engaged, which are very few there, but they actually really hooked in on this. It's more like Scratch and Sphero. I'm not sure. I'd have to look it up. At my school, we don't have a maths club as such. I think, are you meaning sort of more of a wide open thing? We've got the Facebook group. Yeah, lots of questions. I'm losing the context of them all at this point. What's the big takeaway? Hang on. What I will do is I'll go back to our Google form thing, yeah, and just have a quick look. Decimal's all good. Python, not so much. PrimeClimb. Maybe do people want a little bit more info on PrimeClimb, given that it's most people haven't heard of it? So if we go to PrimeClimb, yeah. Okay. So I've got this page on PrimeClimb. That's what it looks like as a game. You can get it at Whitcoll's. It's about somewhere around $50, but you can buy on Dan Finkel's site, you can buy the PDF version and you can print that as many times as you like, basically, and it's $15. His TED Talk is fantastic, and there's online videos and things. So PrimeClimb for the outlay of $15 is well worth getting, reading the rules and having a go. But it takes a little bit of reading the rules to get started. And when you first play it with students, you've got to be prepared to spend more than one lesson on it to get them to understand the rules. I got better at teaching it. But you sort of need a couple of hours really before they're up to speed and they're actually getting the maths out of it and training the students to help each other. So also he has his blank templates for colouring in and that kind of thing, so students can explore the numbers as well. And there's whole lots of teachers' blogs and that kind of stuff with PrimeClimb. So if you Google Math for Love, that's his website. And if you don't know Dan Finkel, he's got lots of videos as well. So he's got free lessons, curriculum, resources, puzzles. He's got tiny polka dots for younger students as well. And so it's well worth having a look at his TED Talk and videos too. So if we were on site, I could actually bring my set of games along and get you to play, because that would actually be kind of cool. But can't really do that online so much. So I don't know if that helps. I think if we just look at rainbow shapes, that's the published version, and here's the code. So for this one, the students got quite inventive and trying different sorts of angles and managed to get stars as well. So I've got to remember how they did it now, and I'm not thinking straight, but nah, they had all sorts of investigations. So I suppose by the time they'd investigated, the thing would be to then get them to articulate why that happened. Ah, there we go, this kind of thing. So they were quite interested. See, here's in range 70, they can change that number and go. And so they would look at each other's designs and go, oh, how do you do that? So the excitement in the class was quite cool. And the way that they learned from each other was also quite cool. So you can see how they ended up with all sorts of wacky designs. For that one, you can see the spiral in the middle happening. So they go, oh, okay, well, I may have to keep going for longer, and what's going to happen? And yeah, so that's the sort of stuff they come up with. They don't think narrowly. They actually have no fear and go for it, and then learn from each other and get all excited, which is fun. But of course, you could get them to write up, why is it, what's happening, why is that working? Does that sound good? I think we're supposed to wrap up so that people can get ready for the next session. But are there any last minute sort of questions or comments?
I might just make a comment myself, Priscilla. I like the way that you set these up for the kids to get in and play with them straight away. Yep. There is a model of teaching about coding where you get students to use things, then modify them, then before they start creating their own. And I think you're doing that, whether you've designed it that way or not. It's a cool way to do it.
Yeah, I find myself when I was learning to code in Python that that I just need to see some working code rather than the manual and play with it, and then all of a sudden you kind of start to pick up the syntax and you can kind of code for yourself. So I've found, like, even with the Python poem, that if I kind of designed the structure and got a working model, they could actually design their own poem by using my structure. So yeah, they do enjoy it. That's cool.
Okay. Well, thank you very much, Priscilla. That was awesome. Still managed to wow me with all the things that you find time to do in a busy life, being a mother and a grandmother and a, you know, sister and a wife. And all
I only
those
work
things.
3 days a week.
I know, but life is
I've got
still
time
really
to
busy.
play.
So, yes,